Ericsson's just completed its 130th deployment of 5G networks globally. We work through mobile network operators, where we've also delivered over 100 million IoT connected devices through 9,000 enterprises, many of which are in the energy and utility sector. You could build, develop and operate your own IoT platform, but why? It's expensive. To build your own, to operate it, it's an extremely expensive thing to do where you require highly technical and skilled staff. So why bother? We've already done it. We've got hundreds of millions of man-years worth of technology knowledge. That's since Ericsson's inception 146 years ago. So why build your own? Why operate your own? Is pointless. Now, if you go with a local mobile network operator, then the SIM card that you have will only work with them. However, if you're roaming from another country, then your SIM will connect into any network that's available. If you use our platform, you get both. You're able to both use what's called eUICC technology, where you can load a profile from one operator, and then at the end of that contract, you can simply send a command to the management platform, which will then switch it onto a different mobile network operator. So where the device, perhaps a smart meter, can be installed and operational for 15 years, the SIM card itself can go with multiple operators over that period by simply sending it a command. Now, if you built your own platform, you can't do that because we sit at the center of a hub of our global mobile network operators. So we can connect to 44,000 roaming agreements in 180 countries. So why would you do it yourself? The rate and speed of change. Neither national utilities or mobile network operators are particularly good at rapid change. But the challenge is that there's always been change, but now it's accelerated. So in the energy and utility sector, if you go back a few years, traditionally then you would collect your energy source. It could be wood, it could be coal, peat. You would then transport it by hand and then you would burn it. And we moved that into the generation world. So we would generate centrally, we would then transmit it, and then we would consume it. We're moving away from that now. We're moving into consumers becoming prosumers, where they're putting energy back into the grid as well as consuming it from the grid. And what that means is rather than everything being centralized, it's now being distributed, which means that you need to have real-time connection points into the network. You need to know if somebody's putting energy into the grid because it's a windy day or it's sunny, how much you owe them. You need to know whether 100 people have just bought electric cars and plugged them into the grid, whether the local transformer that was possibly installed 20, 30 years ago can cope with that. So that rate of change, which utilities aren't used to, it's going to be a challenge for them. And government dictates are that all cars must be electric by a certain date. No national grid in Europe can cope with that. It's not possible. So if everybody did today go and buy an electric vehicle, all grids across Europe probably have to improve by 7-fold. If they connected onto slow, if you wanted to go onto fast chargers, it's 50 times the capacity is required. So unless you've got access to real-time information, they cannot cope with that rate of change, and there will be challenges and issues. So that's probably the biggest problem.